Hey everyone, we're on day 22 now. I guess, you give and you take. I was on time yesterday, and now today I'm about as late as you can get, over 30 minutes late. Also, I said day 22, this is day 21, my bad. Interesting keypad. Oh, interesting. Oh my goodness. It's a lot of robots talking to each other. The length of the shortest sequence. The numeric part of the code. Huh. Okay. Honestly, this input is so short, we can just put it in directly. Just to save a little bit of parsing time. Hopefully that does what I expect it to do. Cool. Okay, now it gets kind of tricky. Oh, because it's just so many nested layers. Like these codes are so long. And like I don't think we can guarantee that the shortest distance, yeah, like there might be multiple short distances for like the first robot, and the second robot might not use any of them. that's quite tricky. Right, so 029A could be typed with left A, up A, 029, and then okay, and then some amount of ups and lefts before hitting A again. Right. Okay, what if we just start with the greedy approach and each layer try to find the shortest at that layer? Yeah, let's try that. So we have shortest numeric. Right, and then shortest directional. So what we return is we basically grab a list for the numeric robot. And then for each of those, what do we want to grab? Yeah, let's do int size equals -1. We can do shortest directional 1. So we just find which one of these has the shortest direction. Right, then we construct a list of I guess we'll do first layer equals okay, so that gets us the shortest stuff for the first layer. Then we need to do everything again. Right, yeah, because this is a potential string S, and this is what's in first layer. So you do one more to get this. Yeah, okay, so int size 2. Actually, no, I need to copy this part. Alright, and then we do find a second layer. And then we can do the same thing. Okay. And then we return something like that. Okay. Now the issue is, how do I get the shortest? So to get the shortest numeric, it'd just be the shortest distance to each number, right? So, oh, that's not trivial though. Yeah, I'm gonna make a hardcode list for each one. So list coordinate numpad, and then list coordinate directional pad. Okay, so let's see how we do. So it's numpad. So let's see, what is 0? 0 would be 0. Oh, yeah, okay, so 0, 1, 2, 3, 1. So 3, 1. And then we'll consider a 10. 1 is 0, 1, 2, 0, so 2, 0. So 1 is 2, 0. 2 is 2, 1. 3 is 2, 2. 4 is 1, 0. And then 1, 1, 1, 2. And 0, 1. 0. So sorry, 0, 0, 0, 1, 0, 2. And finally 0, 1, 2, 3, 0, 1, 2, 3, 2. Okay. So we want the shortest distance basically to each of those points. For shortest numeric, at least. Dang, this feels really hard, actually. Like, okay, yeah, it is actually hard. It took 40 minutes for the top 100 leaderboard to finish. Dang. Yeah. It's unfortunate that I started late today. I feel like, I mean, I'm not done. I'm not even close, but who knows? Maybe if I started on time, I'd had some chance to get top 100 for at least one of the parts. Who knows? Okay, so shortest numeric. So it always ends with A, which is interesting. It's always 4 numbers for what it's worth. Yeah. So we can sort of concatenate the sequence for each, right? Like have a this is going to be very hard coded though, isn't it? Yeah, like let's just take our first one, I guess, just so 803. So there's what, 1, 2, 3, 4 possible paths to 8. Only 1 to 0, and then 2 to 3, and so it's B, what, 3 paths times, oh, it's actually not that bad. It's only like 6 total paths. Okay. Yeah, I'm happy to hard code it then. Alright, so what we can do is basically paths dot add all, what do we call our thing? Numpad, right? Numpad what is this? So let's do paths dot add that to start, and then for int I equals 0, this way we can account for different lengths, even though I think they're all length 4. Who knows, maybe we do part 2 is like 0 803a 803a kind of thing, right? Minus 1 because you're gonna count that, so beginning equals what is this? Let's do string beginning equals put dot char at I, character char end equals input dot char at, actually let's do this. If this is equal to A, then 10, otherwise we want this minus 0. What? How is this a Boolean? I flipped these, that's fine. Okay, I was like, huh? Cool, because then we can do for string path in paths. String. You know, someone was remarking that I do this pattern of like new paths a lot, and it's pretty wasteful line-wise. They're probably right. What am I doing exactly? So for paths and paths, for shortest, so for string addition in shortest numeric helper, numpad.getBeginning, numpad.getEnd. I'm going to add the two together. And then at the end, we want to make paths equal to new paths. Okay, now we just need to do the shortest numeric helper. Okay. So I guess first is if a.x equal b.x. And then if a.y equal b.y. Right, these are sort of the easy cases because there's one obvious route. Yeah, and I think I can pretty easily say that there's no way there's a better route, right? Like, because like 8 to 0, for example, down, down, down on the directional keypad would just basically result in, well, down, 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 which in the next layer would be AAA, right? Which is actually very fast. Versus like some sequence like down, like at the end of the day, you'd still have to press down 3 times. But you'd also have to do other presses. So I think it's strictly worse than going directly there. Okay, so if a.x equals b.x, remember I set x to be this way. So we're talking, yeah, like what would that mean? That would mean like these two. So 1 and 2 are a.x equals b.x, right? So it's only left and rights. Okay, so if a.y greater than, if a.y equal b.y, right? Like if we do the same press, this case never actually happens, but I should code for it anyway. We can just return, let's see. We can just return, we can do result dot, should be results dot add just the string a, and then return. The other option is if a.y greater than b.y, and then obviously there's a if a.y less than. So if a.y is greater than, that means we need to go left, right? So then for I equals 0, I less than a.y minus b.y, we add left. Cool. do results add possibility. And then for the other case, we want to basically do it the other way. Right, okay. And then we can do very similar things here. We don't need to worry about this case because that case is already covered. So these can just be a.x. And then one of them will be up and one of them will be down. So if a.x is greater than, that means it's lower, so we need to go up, I think. Yeah, I think the way I have it right, it would be going up. And some of this would be going down. These would be a dot x's. I mean, yeah, a dot x, b dot x. Cool. Okay, so the next thing to consider is, well, what happens if it's none of these, right? Then it becomes a bit interesting. So there's really four cases then, right? There's a dot x greater than b dot x and a dot y greater than b dot y. Okay, at this point it's clear I would not have made the part 1 leaderboard. Probably not the part 2 leaderboard either. But yeah, these are the four cases to consider, right? So in each one, there'll be two things we can do, right? So there's string possibility 1, which is, let's see, a dot x greater than b dot x, you can go up. The other option is you go, what is this? Why is this unhappy? No, I actually want to keep it in there just for visual clarity. So a dot y greater than b dot y is the left, right? So you can either go up or left. So if you go up, then we basically want to do for remaining, which is shortest numeric helper, new coordinate. Okay, what is this? A dot x plus 1. No, minus 1. Right, because going up is minus, yeah. Comma a dot y, new, and then b. Results dot add remain. Oh, this should just be a string. Remaining plus possibility 1. This will be a dot y minus 1 plus possibility 2. Cool. Okay. Next, so a dot x less than b dot x is this case, so that's a v instead of down, yeah. Which means we want to add 1. Okay, that means this one's also v. also need to add one. Okay, now here this one is R and R, which means add one and add one. Cool. This feels like it should be right, but we can sort of check this. Yeah, what we can do to check this is literally just have list array list result input return result. This is obviously not the actual answer, but this allows us to debug a bit. Let's see if this is right. Now we should print out the thing. Where is it here? Send that out. Print line second layer. So we have up. Oh, we don't include our. Wait, what? What's going on here? There. We should do input plus, so we know which input we're looking at. Yeah, 803 becomes just up arrow? What happened there? That doesn't seem right. I mean, one obvious issue I'm noticing is that we're not starting at the right spot. But that's relatively easily fixable. Like, we always start at A. So basically, we can do Pazza at all. Numpad dot get 10 comma numpad dot get input char at 0. Shortest numeric. Cool. That's one issue, but this doesn't solve everything. So we have left, up, up, up. Yeah, left, up, sure. And then up, left. Yeah, okay, so the first is correct. But then what happened after that? We just sort of gave up. That really shouldn't be the case. For path in paths, all right, and then in addition, we should have new paths dot add. Yeah, something went wrong here for sure. I mean, input dot length is right, like system dot out println input dot length. It should be like 4 or something. Yeah, it's 4. Okay, so like, what is new paths at each stage? New paths is this. Cool. And then it's this. So it looks like there's up, right. Wait, what? Maybe I should just do an example here, right? So system.out. I mean, there's only so many. Let's just literally do one. Numpad.get. Like, how would it get from 0 to 1? There's okay, we can't I just realized we can't go to this point, which is right. I think it says somewhere you can't go into the super bitter cold. Aimed at a gap, it will panic. Okay, so you actually cannot go to, what is this, 0, 1, 2, 3, 0. 3, 0 is sort of off limits. Okay, that's actually good to know. So the only way to get there is if what is the only way to get there? If we need to go left, right, so notice this would be happening at 3, 1. So it's not possible for there to be a greater x. It'd only be in the case where, oh, there's two cases. So okay, the left case is basically you're at 0, and the right case is when you're at 1. Okay, this is actually not the worst, because we can just sort of account for those two cases. So if a dot x equals 3 and a dot y equal 1 and b dot x equal 2, 0, yeah. B dot y equals 0, so 3, 1, yeah, okay. Basically, we have to go up, left, up, left. And new string. Can't do that. New array list. What? Yeah, how do you, what's the correct syntax? Like, add. I don't remember the syntax. Whatever. There's some way to just do that in one step, but whatever. And then we want to flip this to 0, 3, 1. Where now we want to go right then down. Right down. Cool. Okay, so accounted for those cases. So let's do 0, 3 now to see what it suggests. Oh, that's not right. Up and up, right. No, it should be right up, not just up. Huh. Why is it? So, I mean, we can see what case this is, right? It would be the case. So 0, 3 would be what? 0 is 3, 1, and then 3 is 2, 2. Yeah, okay, so 3, 1, 2, 2 would mean what? AX greater than BX, and then AY less than BY. Yeah, so it'd be these cases. So there's up, yeah, which would yield 2, 1 and 2, 2, which should just yield right. Ah, that's where the issue is. This should be the other way around. And same here. Yeah, okay, there we go. That looks much, much better. Okay, so 803. Let's see how this looks now. So left, up, up, up. Yep, that would bring you to 8, right? Left, up, up, up. And down, down, down brings you to 0, yep. And then right up brings you to 3, and then down brings you to A. Cool, okay. So all these look good. Now we gotta do the next layer. Oof, I'm not looking forward to that, given how complicated this was. But yeah, let's do it, I guess. So shortest directional, right? So we need another pad. We can call it directional pad. Is kind of long. Let's call it dir pad. So dir pad dot add. Okay. So now there's 5 symbols here. So we can actually just also have a map. Actually, we can get rid of this. Okay, let's decide on our map first. Dir map equals map.of. What do we want? This would be character as well. Let's do left is 0. Down is 1. Right is 2. Up is 3. And A is 4. Cool. Okay. So now what is left? So left is 1, 0. Right, okay, now what is down? 1, 1. And then right is 1, 2. Up is 0, 1. And A is 0, 2. Somehow, even on an odd day, which is a non-grid day, this should be a lot of grids out here. Okay, cool. But that at least gets us this grid. Cool. So again, we want a shortest directional helper, which is actually going to look very similar to the other helper, now that I think about it. We can probably copy most of it over. The only difference is the top part, I think, will end up being different. The issue is not at 3, 1 and 2, 0. It's now at 1, 0 and 0, 1. Okay, so if you start at 1, 0, then you can only go right up. And if you start at 0, 1, you can only go down left. But then all the other cases should be identical. Cool. So that's shortest directional. And then shortest directional, again, should look relatively similar to shortest numeric. So I'm just going to start with this as the base. The difference is, of course, this is dirpad. And this isn't 10. It would be mapping. They're not called mapping. I call it dir map. Dir map dot get a. Yeah, so those are some changes we needed to make. Let's just see what this returns. Yeah, where does this error? That's a good place to start. Shortest. Oh, this is shortest directional. That? Okay, that's not the only issue. Index 12 out of bounds for length. Oh, right. This doesn't make sense. Dir map dot get input dot char at 0. Similarly, this should be. Actually, this entire thing is just dir map. Dir pad dot get dir map dot get input dot char at. Oh, oops, we don't need this part. Yeah, it's actually way simpler here. Ooh, we're getting closer. Okay, 803A is somehow empty. That's not ideal. Let's do a print at each stage, I guess. See where we're at. System.out.println numeric robots. That first layer. And then now we already have input second layer. Okay, cool. So numeric robots. Cool. So this will get us which S was the shortest. Oh wait, that's yeah. Okay, so there's two different S's that yield the shortest. Cool. So the first one yields, let's see, left AA, left oh wait, what? So this directional keypad must move the up, down, left, right, cause it to move one direction. Right. Whereas A causes, okay. So I think we're a character short because we go left to get to the character, but we still have to press A, right? Yeah, actually, let's do 0. That seems like a reasonable test case. What was the shortest? 029A. Let's run that as our test. So we have oh right, so left, yeah, we need to press A after each set. Okay. Oof, okay. So we gotta do for string paths plus equals A. Always need that A. Okay, so the paths are getting longer, but that's expected. So we have, like, do we see this path, for example? Oh crap, it's not capital V, it's lowercase v. Okay, well that's not ideal. Surely there's a replace feature. Yeah, there is. Okay, so anytime we see capital V, replace it with lowercase v. Cool. No, don't stop opening all the random things. We still don't see this. There's left. All of mine start left up, where it should just start left, huh? For 0. Yeah, that's weird. 3, 2, 3, 1. You'd expect it to just be left. Okay, well, if we ignore that for a second, it still doesn't exist. Oh man. Okay. This is weird. 0, 2, 9. So 0, 2. Yeah, that should be a really easy one. So VVVA is at least always right. But then we see like up, right. Up, right. Oh no, that's actually fine. And then this one's up, right, up, right, up. Okay, that's fine. And then up, oh wait, right, up. Okay, so the 2 to 9 part is fine. And the 0 to 2 part is just up. Oh, so I'm just missing an A. Yeah, this is dumb. This doesn't work. We basically want to do we're going to start with just this to paths.add this and then do one of these. Alright, and then that. Cool. Okay, does this work? Sorry about that. Let's see. Okay, promising. Alright, at least we have the numeric part right. Downside is we now need to change the direction of part some. Yeah, obviously there's ways to shorten that logic, but I'm not going to worry about that for now. Do something like that. Oh, that got very large. Okay, well, let's just check the sequence, right? Oh, that one's not one of the sequences. That's sad. Down, left, left, A. Yeah, that should definitely be one of them, right? Left, left, down. Oh. Left, left, down. But that's explicitly something that we shouldn't be allowing. I thought I made it so that whenever it hit this point, it had to go down left. Did I not do that? No, yeah, down left. Left, left, down. That's not good. How do we end up with left, left, down? I mean, surely it's not all... Wait, what? Down, left, left. Okay, so there is down, left, left, A at least. We do need to fix the other case. Down... Oh, interesting. Down, left, A. To hit down. Wait, but all of them start with left, right? Oh, oops, I'm on the wrong layer. It says this layer. Yeah, why is this not a thing? Oh, it's a thing up to a point. Ah, so it's down. Oh, this should be not A, but blank. I think the same should be true here as well, because we're already adding the A. Okay, let's try again. Okay, so that does exist. But yeah, there's a lot of impossible cases here as well. Left. Yeah, that's strange to me. I don't know how it's possible to go left, left, down, A. Like, that would be what? We're going from... Okay, so that'd be going from A. Actually, we can just print that out as an example case, right? Shortest direction helper, dir pad dot get dir map dot get A to dir map dot get left. Oh, oops, dir pad dot get and then dir pad dot get. So there's left, left, down, left, down, left, and down, left, left. That shouldn't be the case. The left, left, down case is very weird to me. Yeah, that's super strange, because that would imply... let's see which case this falls under, right? So one of the points is... So A is 0, 2, and B is 1, 0. So 0, 2. Right, so it doesn't trigger anything here yet. But then 0, 2, 1, 0. So AX less than BX. And then 1, 0, 0, 2, ay greater than by. So x less than bx, ay greater than by. It's a possibility 1. We go down, right? So now we have what is that? 0, 2, right? So this becomes 0, 1 and 1, 0, which should have already been caught here, right? 0, 1, 1, 0. Yeah, this is confusing to me. How is it not getting caught? Do we ever hit this case? Okay, we do hit it plenty. So that's not the issue. Huh. Like, this doesn't make much sense to me. This case... Actually, yeah, let's get rid of all the other stuff. Right, and just... let's see what this is. Zero, 2, 1, 0. Great, that makes sense. And no other calls. How? Oh my goodness, because I'm calling numeric everywhere instead of directional. That would do it. Ah, there we go. Okay. That looks much better. Cool. So now let's get rid of you and do this test case again. Oh, I need to get rid of all these stupid print statements. Okay, so somehow we're still ending up with nothing, which is not ideal. It's a bit strange, no? Why are we ending up with nothing once we get to layer 2? Are we getting anything here? Well, we're getting something. Let's see if I can find. Yeah, let's try you. No, you're not one of the very many outputs, though. I mean, it seems like there's so many. Why are there so many identical outputs? Oh my goodness. You know what? We're using a set. Oh, I thought I have to change more things, honestly. Okay, everything is a set. Everything's a set. Everything's a set. It seems like there's a lot of duplication. Maybe there's minor differences, but in general, I don't think using a hash set is any downside, so might as well, right? And at least eliminates one thing to worry about. Everything is a set. Okay. Again, this really shouldn't change much once I get rid of all the bugs. Classic statement to make. Oh, get 0 doesn't work now. Oops. Also, I just realized. Yeah, we'll figure a way around the get 0 thing. I'm not too worried about that. But so for string path in paths, size, if size equal -1 or path dot length less than size equal path dot length, then basically we actually want to return result. If size equal path dot length, result dot add path. Should only add the shortest paths basically. And we'll copy this into here. Alright, so it should only get the shortest stuff. And now we gotta worry about this, right? What is a way to get a random element of shortest direction 1? Shortest direction 1 dot iterator dot next. Yeah, let's just do that. You know, my wording here, like what happened here? Shouldn't this be shortest numeric? Oh no, we already do shortest numeric here. Okay, whatever. Doing a bunch of replaces. Okay. Oh my goodness, there's just so much stuff going on. Okay. And what, we just, do we ever get here? I assume the answer is no. No, we never get there. It's kind of crazy, no? Like, there's so much input here. How do we never... Like, what is size 2 here? $68. Oh, it's because I miscopied this line. Okay, yeah, that makes sense. But honestly, why do we need this when we can just do size 2? Yeah, this seems wholly unnecessary. Okay, let's just get rid of all of this. And you. And you. Cool. Okay, now let's bring you back. Oh boy. Yeah, I guess the inputs get kind of long. Well, not the 803. Let's see what 528 looks like. So 5 has 1, 2, 3 ways to get to it. Oh, but then 2 and 8 should be really easy. And then 1, 2, 3, 4. So there's 12 ways to get to 5, 2, 8. Yeah, I mean, that's more, I guess. But, you know, I think I'll finish eventually. Would take a while, but that should be okay. I mean, there's only 5 numbers, right? 1, 2, 3, 4, 5. Yeah. And we're on what? 1, 2, 3, 4. We're on the 4th one right now. Goodness gracious, these are long. Actually, it's really only. No, they're not that long. I think we'll be fine. Oh yeah, there we go. There's an answer. Let's see if that's right. No, dang it. It is not right. That's a bit frustrating. I guess maybe we try the other set of inputs to see what we get. Let's equals u, and u. Remove u. And let's actually not combine the two. Let's have shortest, long, input plus a plus b. That's spaces. And then let's get rid of some of these lines. One, two, yeah, okay, we're off. Which ones are we off by? So we have 68 times 29, 60 times 980, 68. Ooh, I'm saying there's a 64. Interesting. So 179 and 456 I'm off. Okay. Maybe let's just print an element in each one. Cool. So will we print before? Right, like so. Is this? Oh, that's not in here. Okay, that's fine. But this is effectively. Yeah. Okay. So then 179. This one is considered the shortest. Oh no, this is for 4, 5, 6. But we're off on 4, 5, 6 as well. Right, so this, let's just have a char count thing open. Yeah, that's 60 characters, whereas it's saying it should be 64, right? Yeah, okay. So we have. Oh, this is going to be kind of a pain to map it back. Okay, I'm just going to do this. Actually, well, let's do this one here. And then we'll construct what it looks like. So we start on A, we go left down, A, so that's V. We go left AA, so that's down, left. Then we go right, up, right. So we're back at A, AA. Then we go down A, so that's this. Oh goodness, I should be deleting as I go because I've already completely forgotten where I'm at. Okay, so we have, what was it? Left, down, A gave us V, sure. And then, or down, and then left, the A gave us left, left, yeah. And then right, up, right, AA gives us AA, yep. Down A gives us right, yep. And then up, left A gives us up. And then right AA gives us AA. Down A gives us right. Up A gives us A. Left down A gives us down. Right up A gives us A again. Left A is up. Right A is A again. Down, left A is down. Right up A is A. Left A is up. Right A is A. Left down A is down. Left A is left. And then right A is A. A. Down A is right. Then we have up, left A, which is up. And then right A, which is A. Okay. So now we convert this. So we have down, left, left. AA is left, left. Then right, up, AA is up, up. Then right A is right. No, wait. Right A is A. Down A is right. Up A is A again. Down A is right. Up A again. Down left AA is down, down. And then right, up A is A. So we have left, left. Oh no. Left, left, up, up is an illegal sequence to get to A. But it should have been caught at left. Dang it, why didn't you get caught? This is probably an issue in shortest numeric helper then. Well, this is confusing. Okay, I mean we can do an easy quick check though. System.out.println shortest numeric. What was it? 456A. Yeah, there's down, down, left, up, up. That's bad. Why is there down, down? Why is there left, left, up, up? That should be an explicitly disallowed case. Right, because it should give us, like it should hit, once the first left is hit, it should force us to go left, up. Also, who is texting me? I have 13 text messages. Kind of weird. I swear that count wasn't 13 when I started this. Oh, not very important. 3210. Yep. 2210. Can we somehow record? Yeah, so here we can do. Oh no, this is actually quite difficult to record which one's which. All right, whatever. 3210, 2210. Yeah, okay, so that one's fine. 1, 2, yep. So that one goes A to 3 to 2. Sure. There's 2, 1, 1, 0. 2, 1. Wait. So 3, 2, 0, 1, 2, 1. Okay, so 2, 1 is 2? Wait, what is 2, 2 is 3? Okay, so this is right. So A to 4 is one path is to go 3 to 4. That path could then go 1, so 6 to 4, or it could go 3 to 4. Sure. 1, 1. So this is what? 5 to 4? Alternatively, it can come from 2, 0, which is 1 to 4. Yep. Yeah, this is the bad case. How in the world are we ending up at 3, 1? Alright, like that's real bad. 3, 0. Looks like it's coming from 2, 0, which is interesting. That's AX plus 1. Which is one of these cases, but that's impossible, right? Because going... Yeah, that shouldn't be possible at all, but it's happening after 2, 0. Oof. This kind of hurts my brain. This really hurts my brain. How is this possibly happening? Like, what could lead to... What could lead to 3, 0 here? That's what's crazy to me. Because it happens... Yeah, it definitely... I mean, it definitely happens. I see it happening. The issue is what is leading to it to happen. Because I see I see right before it is 2, 0, 1, 0. But that should never take you... Yeah, like this is so weird to me. Like what could possibly... Let's just do 4 actually, just for simplicity. Yeah, I definitely see left, left, up. 3, 2, 3, 1, 3, 0. Three, 0 is crazy. Okay, let's do this. Starting... Yeah, okay. Coming from... gonna be fun cleaning up all these print lines afterwards, but that's a future me problem. Also running out of battery. Let me check that. Okay, so starting. Coming from 3110. What in the world? I have literally 3110. Aha. Okay. I think I get what's going on. If right. 3110 doesn't have to go through 3120, which is a mistake I made. Okay. Luckily, this is a pretty constrained set of issues. Right, like it has to be coming from a specific case, like 3110. The only time you'd ever go left is 3110. So what is that? So 31, so AX greater than BX, and AY also greater than BY. Yes, so it's only this case. If it's this case, if a dot x equal 3 and a dot y equal 1, right? If not this, or not this, then we consider this one. Otherwise we don't. No, dang it, I still see left, up, which is strange because I don't see 3, 0 anymore. So where does left, up come from now? Because the other ones are fine. Left, up is totally reasonable. Left, up, left, and left. I'm sorry, up, left. But left, up shouldn't be possible. Right, so starting 1, 0. Yeah, this makes very little sense. Maybe I should just convert these cases as well. Yeah, honestly, what if I do that? Like every time I do up, I do that, and then this one can be down. This one can be right. And this one can be left. Something like that. Still no 3-0. How in the world are we getting left? This is wild to me. Oh. I guess I'm not labeling some of these, but still. Yeah, this is bonkers to me. Oh, I really goofed this up. One of these should be down. Is this one down? Oops. Okay, yeah, that doesn't change anything, but yeah, gotta make sure I don't mess that up. Okay, well, let's only list the cases where we go left. I'm so confused where we're getting left from. Well, I mean, not where we're getting left, but we're getting double left from, I guess. So, wait. No, there's still a couple. So, only lefts. Cool, okay. So we start at 3-2. Yeah. 2-2. Okay, that's up. That's why it's not showing anything. 1-2. Yep. And then from 1-2, we go to 1-1 and we go to 1-0. Cool. That's up, left. The case is literally not here. What? Am I flipping my ups and my lefts? Because that's what's happening. So when I go left, I'm decrementing this by 1. So 3-2 becomes 3-1. No, that is definitely left, right? Because 3-2 is A and 3-1 is 0. Yeah. No, my lefts seem right. Wow, okay, that statement. That's quite a statement to make. But yeah, actually now that I see, there is no up, left, which is interesting, because there should be. Am I adding it? Oh, I'm adding all of these inverted, aren't I? That's what's going on. It should be possibility happens first, plus remaining. Oh my goodness. Oh, I gotta invert absolutely everything. Okay, at least I know what's going on. It's kind of annoying, but it's fine. It's also why you shouldn't duplicate code so much. It's a fun lesson, yeah. Cool. Not too bad though. One day I'll definitely clean this up a lot. Yeah, I'll need to do this all for shortest directional as well. Shortest directional helper. Let's see, remaining plus possibility 1. Yeah, that should be possibility 1 plus remaining. Cool, and this should be possibility 2. A lot of copy and pasting today. You know, I feel like this is a pretty hard day though, so I'm not too worried about the fact that this took an hour and a half. Oops, I went too far. Is that everything? Remaining plus. No results. Alright, let's give it a shot. Yeah, there we go. Okay. Do I feel confident? No. Let's run the example again. Also, we're about to do a mega replace. System out will replace with dash system dot out. I just have too many print statements. Okay, actually I need to keep, oh no, I don't need to keep that one in. 1, 2, 6. That looks good. Okay, let's switch off the example. It's weird that the non-example one takes so much longer. I guess maybe the examples are the easy cases. Yeah, I guess it's not too crazy. Imagine they wanted to make sure the example cases run relatively quickly, just for the sake of testing. I think that actually makes quite a lot of sense. It seems like 803 is a real doozy for what it's worth. I guess, yeah, because 8 has 4 and then 3 has 2. It doesn't seem that bad though, right? 803, yeah. 76, yeah, it's quite a long one comparatively. I guess it like snowballs though, right? Because if you have relatively long sequences, then the amount of time taking sort of increases exponentially. Okay, what's an answer? Oh, that's bad. Okay, that's really bad, because I'm worried that that suggests the naive greedy solution isn't right. Right, because there might be cases where it's actually faster to go a different route. Oh, but the amount of the amount of cases to check that is kind of nuts, no? Oh boy. Yeah, this is tricky because I don't even know exactly what to look for at this point, right? And I can make sure, I guess, that I'm not doing anything. 803, 528, 586, 341, 319. Okay, those all look right. 803, 528. Yeah, so there's no issues with like multiplying by 0 or any nonsense like that. Everything looks good there. And like the lengths aren't crazy wrong. Oh, bless me. Yeah, that's real bad. There's nothing that's like obviously wrong that I see here, right? Like, I mean, it works for every example input, right? So it can't be that wrong. Yeah. Okay, I mean, so one option we have is to just not run U, right, and just always add U. Whoa, I just made so many things. What did I just do? How do you have multiple layers? Okay. This will make it so slow though. Yeah, it's quite unfortunate. It's also maybe still not right. Because I actually prune in multiple places, right? Yikes. Oh, I also should have recorded what my previous results were. It's not good. I mean, 76, I think it was like 76, 68, 68 something. Yeah, it's so much slower. Oh, that has been like my theme this year, apparently, is writing incredibly non-performant code. I don't know if any of you watch my or read my blog, but I do mention it there. Like last year, I tried very hard to keep everything sub 1 second, like as in all 50 parts, not as in one day, which meant what? I was averaging 20 milliseconds per part. Today, I'm out here averaging 500 seconds per half day, so we're really at a different level here. Okay, 76, 70, 68. I think it was 76, 70, 68, 68, 70. So if we end up with that again, we've somehow not done anything. That would be unfortunate. But you know, very possible. Oh, the other thing is I gotta be up by 8 a.m. tomorrow, unfortunately, because I have a tutoring thing I do at 8 a.m. every Saturday. Well, I don't do it at 8 a.m. It's at 9:15 a.m. But it's a bit of a distance away from where I am. Oh no, 76, 70, 68, 68. This is really looking like I'm about to get the same number again. And the issue is I also have completely forgotten what number I got. It's like 1, 2, 1, 8, 1, 8 something. No, that's definitely the number I got before. Well, I'll try it anyway. Dang it. The answer is too low. Wait, too low? Oh, that is unexpected. I thought maybe I was missing a more efficient path. But this is saying I'm actually coming up with an illegal path, which is a very different story. Oh, okay, okay. That's actually good. I should have checked that first. I don't know why I didn't look at that. I guess maybe it didn't say it was too low the first time I input it. Like maybe that's Topaz being nice and being like, yo, you idiot, stop trying the same value, try something higher / lower. I don't know. Maybe it is, maybe it isn't. Who knows? Okay, but let's bring this back. This didn't seem like the issue. 183354. I'll just write that down here. 183354 is what we got. Yeah, also I can literally just add it in here, right? I do first layer equals new array list, and then first dot add all. Oh, I can also feel my computer heating up, which is always a great sign. Okay, this should speed it up slightly. Well, if it compiled, which is never a given. What? Didn't I just add a semicolon here? Oh, I see. The real mistake was also the extra parentheses. How is the tool? I mean, it must be that I'm just like oh, maybe I'm cheating here. How am I? Oh, that's it, isn't it? If I go here to here, I run into the same issue. Yeah. No, I know what the issue is. Wait, what? Also, my numbers changed. How did my numbers change? They all got worse. Huh? Wait, but that was supposed to be a no-op. I mean, I'll try this, but like nothing should have changed. Yeah, okay. I gotta wait 5 minutes now. That's fine, but what in the world? How did the number change? That hurts my brain. Oh, I'm only adding it. Okay, never mind. We're gonna undo this. There's a way to do this properly. I can't think of it. I'll do the slow way. That requires less brain power. Okay, let's go back to here. And then I just gotta get rid of that one illegal case and I should be good. On one hand, it's quite bad that I'm now dealing with a timeout of 5 minutes. On the other hand, my code takes about 5 minutes to run anyway, so could be worse, could be worse. Okay, in the meantime, let's deal with the case I know I'm not doing right. Shortest directional. It'd be left to A, right? Let's just make sure that's the incorrect case. System.out.print shortest directional helper. Oh, my coat is falling off my chair. 1 second. Okay, my bad, I'm back. dirpad.get, dirmap.get. That one, comma, dirpad.get, dirmap.get. That one. This is the same issue I was having in the other case, right? Yep. There's a up first. Yeah, I cannot have that. Okay, cool. Good thing is, I know how to fix this case. So, let's see. So, this would be from 1, 0 to 0, 2. So 1, 0, 0, 2 means AX greater than BX and AY less than BY. Right? 1, 0, yeah, okay. So we can only have this case. So if not A.x equal 1 or, actually we don't need the or here, right? Well, we'll include it just in case. A.y not A.y equals 0. Then we do this case. This should technically make the code slightly faster. Yeah, okay, that's good. Oh, that made the code surprisingly faster. And of course it didn't change anything. What? That's what I already had. Oh no. I really thought that was it. Is there a different case that I'm missing here? I mean, maybe I just check a bunch of these helper cases to see if any of them look wrong. Let's do this to up, left to down. Actually, yeah, let's just do all the left cases, eh? Why not? Just to see what they look like. So we got right, up, right, up, right, up, right, right, right. Okay, so all those cases look good. So now let's do all the cases from A. There's nothing. There's the left. There's down left and left down. Yep, there's down, and then there's left down left and down left left. Okay, those all look good. I don't really see what other cases could have gotchas. I guess maybe something with up. So let's try all the up ones. Have right, nothing, down, down right, right down, down left. Okay, those all look good. Okay, so I suspect that maybe it's not with directional helper then. Could be with numeric helper. Numeric helper. So we can do like numpad.get. What do I want to try? Numpad.get 1. Oh, we need a lot of these cases. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let's see, 1, 0. Oh, we want to include 0 to itself as well. Not that I think 0 to 0 here is wrong, but just so we have the whole suite. Also, let's get rid of this for now, so we can ignore that nonsense. Cool. It's very fast. Yep. 0 to 0 is nothing. Cool. 0 to 1 is up left. Yep. 0 to 2 is up. Yep. 0 to 3 is up right or right up. Yep. 0 to 4 is either up left up or up up left. That sounds good. 0 to 5 up up. Yep. 0 to 6 is right up 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 right right up right up right up. Yep. 0 to 7 is up 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 left up left up 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 left up. Yep. 0 to 8 up 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 up. Yep. And then 0 to 9 is up left up 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 left. Oh, sorry, right up up right up right up up up. Yep. Okay, those all look right. Let's try 1 now to each one. Oh, actually, that's probably it, huh? 1 to A is probably wrong. 1 to A, yeah, there's down, right. That's exactly the issue. Okay, so every time we go, one more special case. Oh my goodness, I feel like I'm like that one meme. It's like, yeah, just one more special case. I promise you, just one more. It's like, I don't know, I sound like an addict of special cases. I mean, my code is already, what, 360 lines long? So clearly I'm not opposed to adding special cases. Okay, so we have this one for greater than, so we actually need one for less than. Yeah, okay, where's less than? Here. Basically, we need to be careful when we go down. So 1, 0, wait, no. Which one was it? 0, 2, 0, right? 2, 0. Then we can go down. Otherwise we can't. Wait, what? Oh, I commented out everything and went, huh, why'd nothing run? Of course nothing's gonna run. Okay. So now we have 1 to 10, you have, okay, so that did catch that case. Now let's uncomment the actual stuff. You know, it's honestly, it's not that slow. Okay, that's greater than my other number. Oh my goodness, I got it right. Let's go. Okay. A second member is also, oh my goodness. I'm telling you, these historians, they're absolutely worthless. There's many more robots involved. In summary, there's the directional, 25 directional. Of course, there's 25 directional. Oh my goodness. Okay. That's real bad because my current solution is already extraordinarily slow for 2 layers of directional. To get 5 layers of directional, that's real bad. I mean, theoretically, my code could easily work with 25 layers. I just might have to wait to the heat death of the universe. Actually, it probably wouldn't work, right? Because Java would because of the amount of stuff I'm trying to shove into memory. Okay, so what is a better way to do this? I think the reality is there's only one optimal path for each thing, right? Like at the end of the day, every path goes back to A. So there's only so many paths to consider. Yeah, I mean, let's just think this through, right? Like if you're going to go up left, I guess it's about the same, right? Is there any path where it's different choosing between up left and left up? So it's like, okay, let's just take a quick look, right? So left up, we start at A, of course. So we go, left up becomes, there's quite a few paths for this. Maybe we do, oh my goodness, there's a few paths for absolutely everything, huh? Okay, let's do down right. So we can do down first. There's a few ways to do that. We can go down left A, so we're doing down right. So right A, up A. Or alternatively, rather than going down left, we can go left down A, right A, up A. There's sort of 2 paths, right? The other options are, of course, let me just record these as the possible options this way. The other option is to do the right first, so it'd be down A, left A, and then we can go upright A, or we can go right up. Upright, upright A, or we can do down A, left A, right up A. So this is what? 1, 2, 3. So all these are 1, 2, 3, 7 characters. Interesting. So then, like, what is the difference? Like down, up, and down, left, left, up all seem kind of similar, no? I mean, if left down, right, is always the same as down left. I haven't said that's necessarily the case. I'm just saying, like, if it is, we can just only include one, right? Like, there's no reason to do both if that's the case. Like, basically, how bad would it be to just remove some of the cases, right? Like let's prioritize moving, I don't know, up, down first, right? So that would mean taking U out. Actually, let's only do this for directional. I mean, we have many more directionals, right? So if we remove, what is it? We remove like this case, this, oh no, we need to remove this one, and this one. Like, what if we remove those cases, right? the same answer, huh? And it's way faster. Interesting. So now the obvious question is, can we do this for numeric as well? We cannot. That's strange to me. Why would numeric be different? Like if numeric goes up, 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 left, left. Oh, that is different. Yeah, it's actually, it has to be different because like up, up, left, left, and up, left are not the same, because in one case on the directional pad you can just press AA, right, to do it twice, versus the other one you have to constantly move. Okay, so numeric cannot be done that way. Well, that leads to the obvious question, why is it that the directional can be done that way? Because like left, left, like left, down, left versus down, left, left should be different then, right? Because down, left, left should be more efficient. Oh, but we're doing up, downs first. I think we're prioritizing up, downs. In the case that we need to go left. Yeah. And then we prioritize going right, which is good as well, because then we can get the two. Okay, so this is actually the correct series, right? Oh wait, did I undo the changes? No, I didn't. Let me undo the numeric changes, which are wrong. I cannot do this for numeric. Only for directional. Oops, I'm on directional right now. Cool. Okay. So I'm actually just gonna, I know this is not optimal speed coding, but I'm just gonna remove a bunch of stuff just to clean up the code a little bit, because at this point, like, the code is extremely long and extremely unreadable. Obviously I won't do like a super deep refactor right now. I don't think that's worth the time, but I do want to at least clean this up a little bit. Cool. So notably now at each step there is a single path. Yes, there's always one, which means now the complexity is not exponential. Which is good. Now, to be clear, it is still slower each cycle just because there's more things to check. But I'm hoping that this slowness is not enough to matter here. So we'll just add in a part 1. And basically we want to do for int I equals 0, I less than part 1, 2, otherwise 25 was it? Yeah, we start at layer 1 though. We can do why do I choose a list for that? Set current layer equals numeric robots. Oh, oops. Cool. So we want basically set string new layer equals new array list. No, new array list. What am I doing? New hash set. I'm going kind of crazy given it's almost 3 a.m. Then we do for string s in current layer. New layer dot add all shortest directional s. I like how I said add all and then just did not type add all. Yeah, we're kind of the delirious phase, I guess. Current layer dot iterator dot next dot length. Current layer equals new layer. Does this work? Not in the slightest. Maybe this is supposed to be 0. Oh, that's bad. What? Should not be changing, right? Yeah, okay, it's always 8. Well, 12. Sure. Why are these numbers higher? Oh, wait, this doesn't do anything, right? Now, what is going on, huh? Oh, this is very strange to me. Okay, wait, let's, here, actually, I'm gonna copy this state, because it's like the cleanest exit state, and then I'm gonna go back, though, to the working state, which is before I add the boolean in. Actually, right after I add the boolean in. Hopefully IntelliJ can go back that far. Okay, so this state is correct, right? Yeah, okay. So I'm going to quickly compare this state to this one to see what's the difference. Like, what happens if I remove this? Is it still right? No, not at all. Oh, right. What if I remove this? Okay, it is still right, which means I don't need this. Yeah, okay, that wasn't the issue. Oh, is the issue just that I need to do a min, like rather than... Oh, that'd be pretty funny. I mean, I think it is the issue, right? No. Dang it. I really thought that was it. Oh. What is going on? Okay, here. Let's do this. Let's print out the current layer. Okay. So we start with up, 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 left A. Up, 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 left A. Okay. Down, down, down A. Right, up A. Down A. Yep. Then the next layer we have, well, actually, do we have the thing we care about, which is like, so we do have this, right? No, because this is the wrong thing. Okay. Okay, let's change the first input. I hope I remember to change it back. Well, if I don't, it's not the worst. 029A, 029A. Alright, so 029A should be 68, but it's 76. Good way to check. Okay. No, stop putting it there. Here. Yep, okay. Sequence does exist. Then does this sequence exist? It does not. Dang, okay. So there's down, left, left, A, right, right, up, A, left, A, right, A, okay, and then there's down A, why are there only 3 cases here? That seems kind of low, no? Well, actually, what is the length of this? I have chart count up. 28? What is the length of like this one? 30. And then the length of this one, 91. So this one is 28. This one's also 28. Okay. So there's definitely a few with 28. But like having extra shouldn't hurt. In fact, this is weird though. Like these, okay, obviously the 30 case is wrong. Then we have left, left, and then right, right, up, left. I mean, these cases only differ on these steps. But I thought we showed that down. Yeah, going down left. Is that different than going left down? No, right? So down. Yeah, down left. Oh, wait, it is different. Right, sorry, left. Wait. Left down should be prioritized over down left. Because left, you can sort of get that bonus boost. So where is that? So that's not a numeric. It's in the directional helper. But we want to go. We want to go. We'd rather go left down than down left, is basically what I'm saying. So like if we're able to do both, we should prioritize the left case, I think. And then I don't think right matters. Yeah, I think it's just left where it's important to go left first. Oh wait, wait, sorry, this is not the right place to be changing stuff. This is in the X section. I want to change it for the Y's. If AY greater than BY and AX greater than BX. So AY greater than BY, yeah, we should go left instead. Okay, that didn't work. Oh, we also want to go left first in this case. Not in this one. Oh yes, in this one. That didn't work. It's kind of weird, right? Like, when would we ever want to prioritize anything else? Oh no, we do want to prioritize going down if it's to the left. Wait, what am I doing? Oh, my brain hurts. Wait. So left, like left up beats up left. Yes. I'm not gonna, there's only so few cases. Maybe I should just hard code them all. Like, at this point my logic is longer, I think, than if I just there's literally, how many cases are there? There's 5 times 5, there's 25 cases, 5 of which are identical, which I can code instantly. I mean, I already have so many cases hard coded, right? I mean, these I think are trivial, but also cover most of the cases. Yeah, like straight up, maybe I just get rid of this nonsense. I mean, we're doing 1-to-1 ratios anyways. We might as well just not have these. Okay. So basically, we just want a few more of these. How many more of these do we care about? Basically, anything where it's not directly up, down, or left, or right. So from A, we care about A here and A here. Okay, cool. That's 2 cases. A is 0, 2. 0, 2, 0, 2. Now, what cases do we care about? We care about 1, 0, and 1, 1. 1, 0, and 1, 1. Okay, so if it's A to left, we want to go down, left, left. Down, left, left. That beats left, down, left. Okay, now if we want to go A to here, we want to go left, down, left, down. Okay, that's all of our A cases done. All right, okay, next we have the right arrow case. That's where we start at 1, 2, and we need to go to 0, 1. So in this case, what do we got? We want to go left, then up. Yeah, left, then up. Left, then up. Cool. Okay. Now we got the inverse of the other A case, right? So we start at 1, 1, and we need to go to 0, 2. 1, 1, we need to go to 0, 2. So in this case, we would rather go, what, right, right, up, and upright don't matter. So let's just choose one at random. Right, up. Okay, then we have the case where we go from there, which is what? We'll go from 1, 0 to 0, 2, where we go right, right, up, right, right, up. And then finally we have the case where we go from, what, 0, 1 to 1, 2. 0, 1 to 1, 2. Well, do we have a preference between right, down, and down, right? No, I don't think so. Let's just choose right, down. Oof, okay, that's not good. And the only difference, so it went up, right? It went right up instead of right up, right? That shouldn't matter at all. Yeah. We have this case. Okay, that's 2 longer. Wait. Oh, wait, what? How are you possibly at 76? This is 68 characters. Right? This one? Yeah. Oh my goodness. That is some nonsense. Okay. Let's switch you back. I don't even think I changed anything meaningful. I'm not gonna lie to you. I think I spent all that time changing nothing of value. 184718, is that right? It is, okay. And now let's set this to 25. Oh, these prints are gonna be terrible. Let's stop printing. Stop printing. Wait, what? Oh, here. Wrong stop printing. The layers are still gonna get quite big. Oh man, the layers are much bigger than I thought. I mean, at each point we're roughly doubling. Oh, that will kill this, won't it? Yeah, wait a second. The numbers are gonna get gigantic. Right. Yeah, no, they're gonna get absolutely humongous. I didn't think about that, to be honest with you. How about this? Let's just try a few cases. Like 3, how much does it go up by? Oof, they're different amounts, huh? But like, I think I'm roughly right on the growth rate, right? It's like between 2x and 3x. Yeah, okay, let's do 3, 4. Obviously, we're not getting to 25. This is gonna be crazy. Four, 6, 6, yeah. I mean, how high can we go here, right? So if we do 6, is that fine, or is that gonna take a while? 6 is pretty instant. What about 10? Okay, 10 is not instant. Let's try 8. Okay, 8 is not instant, but still doable. Yeah, 25 is beyond hope. But yeah, there's quite a lot of separation building up here. I mean, obviously, that doesn't take an expert to see. Interestingly, the second and third case are always 2 apart. I don't know if that's actually helpful for anything. The bottom case is by far the best. Okay, this feels like one of those classic problems where it's like you can't simulate. Oh, I see what I might be able to do. I can probably simulate, right? Like the classic, you can't simulate the whole thing. You have to simulate parts of it. I think I know what to do. I can split on the A's, right? And simulate each of those. Yeah. Okay, so we'll do, and then if not part 1, we'll do some stuff, but this should result, yeah, okay. This is the key. So we have to do 23 layers of something else. Map, string, integer, a parts. Let's just do parts. Basically, the idea is each section between the A's is a static section that I can consider. So what I want to do is actually, I wonder how many times do I end up hitting this? Win. Oops. Actually, wait, let's do this. If results. This is hard coded, but that's fine. Ugh, okay, there's multiple. Cool. Let's do this. Iterate for a string s in current layer. Map parts equals iterate s, comma 23. And then for we have like on interim results equals 0, and then for string s, I already have an s, val, no, key in what is this, parts.keyset, we can add each one, remember, plus the a's at the end. So we can do interim results plus equals parts.get key times key.length plus 1. If interim, if results equal to -1, or results greater than interim result, result equals interim result. Cool. Now I just need to build out iterate. So I can basically make cool. So if we have no iteration cycles, we basically want to special case this one, I think. Actually, yeah, we want to just have like a iterate 1 kind of thing. Iterate 1. No, actually we can just do while. Yeah, okay, let's do map. We want to come up with basically a way to turn the string into a map of the various parts. Right, and then we can just do map equals iterate 1 map. And then we can return map. This feels like the very Java-esque way. Very short methods, right, is the goal. So basically for string s in map.keyset, this is where we do all of these cases, right? So it's like, yeah, like if s dot equals, and there's a bunch of things that s could equal, right? So it could be like, actually, how many are there in total, right? There's not that many. Okay, so let's consider all the, so there's the nothing one, right? Where you just press A. And that one is trivial because you can just map it to nothing again, right? Like if it goes A, then your now new one is A. Okay. Okay, next case, let's consider the rights. So we have right. Which case is right? So right would map to down, and then so one down and one up. So down, imagine knowing which way is down. Right, then we want to do Are ints big enough? Do I need longs for this? 2 to the 25th? Ugh, okay, never mind. We're doing longs. Because I am quite concerned. On the bright side, I'm taking long enough that I'm no longer very upset about starting 35 minutes late. Yeah, I guess my IDE was even warning me there, huh? Don't use whatever I was using. Okay, so long first equals getter default map.getter default that. Then we want to put first plus map.get s. Actually, yeah, let's just long val equals map.get s. I get it. I should be using an entry set instead of the key set. Not gonna try to. I don't have the brain power left to figure out how to do that, so I'm gonna not worry about it. Okay, so remember it's down and then up. Down and then up. Cool. Okay, so that's right. Now we just knew that for every case. Oh man. Even more code duplication. Love that. I guess in reality, do we even need this part? Maybe we do. I feel like we probably don't though, but I'll keep it in for now. Also, yeah, let's do convert as well. I mean, this iterate one is just going to be a bunch of nonsense. So I guess the first thing to do is do s.split on a, and then for string part, oh actually yeah, we need a result. Can do map dot, sorry, result dot put part, comma, result dot get or default, part 0 plus 1, something like that, and then return result. Okay, so that should get us convert done. Now I gotta do all the other cases of this. So we have this, right? Actually, let's just copy this one because the next one's gonna be very similar. I'm gonna do right. So right is very similar. It's down a and then up. So a second is actually this, and then there's a third step, which is going up. Yeah, so we go down, press A, go back up. There's no right. It's not possible, so we can now go to the left cases. So there's left, one, and then there's going to be left. So for left, to go left, we need to go what? Down, left, A, and then right, up, A. Yeah, left is quite painful. Okay, but I mean, we know what to do. So left is, what is this? Down, left, left, down, left, left, and then right, right, up, right, right, up. No third case for here. Okay, so then the next case is left, left, which is very similar. Down, left, left, down, left, left, and then we have right, right, up, right, right, up. Cool. So now we have nothing, right, 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 left, left, left. Now we have to do up and down, I guess, as the next two. So let's do up and down. Okay, so what is up? Up is left, right. Okay, so up is relatively simple. Left, right. Now what is down? Down is a bit more. It'd be left, down. Yeah, left, down, A. Right, up, A, something like that. So this would be still only two things to do. I also notice you can never have down, down, or up, up because the grid is only size 2. So this should be what? Left, down, right, up, right, up. Okay, so now we have all the pure cases done. We just have to do the other ones, and we know how many other ones there are because they're all listed here. So I'm just going to look here. I'm going to write it down on paper for now. Right, up, down, left, 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 down, left, up, right, up, right, right, up, right, down. Okay, I think that's all of them. Did I just say any duplicates? I did. So right, up, I said twice. Did I say anything else twice? I don't think so. So it looks like I have 6 cases to deal with. Cool. And then we want to do a return result at the end. Cool. Yeah, you know, I'm just gonna try this. Well, we'll try this after in a sec. Let's first finish this. So okay, we have a few more cases to do. Here we have, what did I say? Let's do the larger cases first. Actually, get them out of the way. So left, down, down. Left, down, down would require what? Down, left, left, A, and then right, AA, right, up, A. This is down, left, left. Wait. Down, left, left. Oh, not left, down, down. Oops. Left, down, down is not even a case, so I don't know why I was looking at that. Down is down, left, and then left, AA, right, right, up, A. We gotta do that. So we had down, left, then for second we have left, And then for third, we have empty string. And then for fourth, we have right, up. Cool. Okay, now let's do the next case, which is right, up. Cool. So right, up. Right, up. What is the string we want for right, up? So right is down A, and then up would be what? Left, up, A, and then we have to return, so that's just right A. Down A gets us right, and then left up gets us up. Yeah, cool. So here we have down as our first one, then we have nothing as our second one, then we have left up as our third one, then we have right as our fourth one. Cool. Okay, so that's two of the cases done. And now we have left up, left down, right up, right down. Okay. These cases feel like they're kind of similar to the ones I've already done. Oh well, we'll just redo them. So let's start with the right cases. So I'll copy from here. Right down. Okay, so how do I do right down? Right down is down A, right down. So then left A, then right up A. Oh my god, this is terrible because the thing is, I'm doing so many cases manually that the chance I get any one case wrong is exceedingly high. Oh well, it is what it is. I'm locked into this at this point. It's 3:30 a.m. I'm hoping to be done by 4. I'm getting maybe 4 hours of sleep at this point. We're doing great. Let's see, down A, and then we have left A, and then we're gonna have right up, right up. Okay, now we just need to do, what is this? The next case is, so we just did right down. So let's do right up. So right up is pretty much right. I have a right up case, right? Yeah, I can just copy this one and remove one of the things. So I don't need to worry about this A, so I can get rid of this one. Cool. Okay, so that's right up done. We can do down left next, given that's also an easy one. Down left, because we have down left. Again, we can copy from here and then remove the duplicate A. Down left, remove the duplicate A, remove this one. Cool, so that's down left done. So now we just have left down and left up to do. Yeah, sure, why not? I'll copy this one. Left down. Okay, what is left down? Left is down, left, A. So left and then down, so right A, right up A. left, down, left, left, and then right, right, and then right up, right up. Cool. Okay, and then the final case. Left up. Left up is down, left, left, A, right up, A, right, A. So we have down, left, left, A, and then right, up, and then just right. Cool. I mean, that's an answer. It's probably not right given how much I manually did, but no. Okay. Okay, at least one thing I can try is part 1, 2, else 25. I can get rid of this. Okay. So something's obviously not right. Given these numbers are so tiny. Part 1. Let's go see what went wrong. Huh? There's just nothing. What the? How is there nothing? How is that even possible that there's nothing? Oh, if not part 1. Wow, crazy. Am I 1 cycle off? Like, should this be 3? No. Oh, gosh, that's not good. Why does this approach not work? Okay, I mean, I guess the obvious thing to do. First of all, this is some nonsense, but it's fine. We'll keep it in. Let's print out what convert would look like, right? Okay, so up, 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 left. Oh, we definitely need to do one wave, because like up, up, up is not even a thing. Okay, wait, undo. We do one layer. We do one layer. Right, and then we do let's do that. How do you work? Not at all. F me. Alright, at least this should be closer though. Alright. Yeah, so there's blanks up, right. Sorry, right up. Did I do right up as a case? Down, left, right. Ugh, my brain hurts. Like, are these all cases I have? Let's see. So there's the empty case, yeah. Now is there right up? Right up, yeah. right down also is a case? Is down left a case? Looks like it. Down left. And then is... Okay, let's just do these individually. So right up. Cool. Right up is a case. Down left is a case. Right down is a case. Left down is a case. Left is a case. Right is a case. Up is a case. Okay. Right up is a case. Left, oh, sorry. Down, left, left is a case. Down, right, left is a case. Left, down is a case. Okay. Right up, yep. Down, left. Right, down. I mean, the most likely thing is I just did some case wrong, right? Like, it seems so likely that just somewhere I effed up. Ugh. Trying to find where I effed up, that is not easy. Yeah, that's tremendously not easy. I mean, somewhere in here, probably. The thing is, once you go to maps, you lose order, so I can't just look at the inputs and just be like, aha, it's that. Oh, ho, wait. Oh no, that's just left. I can't even. I'm going crazy out here. Okay. Well, there's right up. Is that a thing? Okay, right up is a thing. So it feels like all these cases are accounted for. Maybe not correctly, but they're accounted for. It is weird that 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I guess some of them still have 8 cases. Well, I mean, I could just go through and see if I have any case that looks wrong. Right, so I have right. So right A should become actually, okay, let's imagine I just have A, right? Like if it's A, then it's just A for all eternity. Okay, that's fine. Oh wait, I should do that. I mean, that's not the only issue, I'm sure, but it's a issue. Okay. Is there any other obvious issues like that? I don't think so. Yeah, I'm not seeing anything super obvious. I mean, shortest numeric is right at this point. I'm gonna just close you down. Okay, actually, yeah, let's just go through all the cases here to make sure I've added all of these in. So we have right, up, down, left, left, down, left, up, right, up, right, up, right, down. Yeah, let me make sure all of these are in here. So we have right, up, yep, left, down, yep, down, left, yep, left, down, yep, left, up, right, right down. Cool. I do see every case. And there's no weirdness here. Like there's no left, down. Yeah, no left, up either. Okay. Which makes sense because you can't go left, and then up or down. Yeah. Okay, cool. Okay, it seems promising. Is there any up, left? No, good. Up, right. Okay. Is there any down, left? Oh, there is down, left. That's wrong, though, right? We would rather have left, down? Right, like, do we even have a case for down, left? Oh, we do. Why do we have a case for that? Down. Like, shouldn't I be going left, down here? Oh, I have to go down, left in some cases. Ah, right. But I should be going, in this case, I should be going left, down. Okay. I mean, that's definitely a mistake, but glad I fixed it. Where else am I going down, left? So that, yeah. That one has to go. Here. Down. Right, so if I start going down, then I should be going left, down. Left, down. And like left, down is a case, right? Yeah. Okay. This is another improvement. The issue is my number's too low, so I shouldn't actually be looking for improvements in theory. I mean, okay, let's go back to the 029 case. Alright, so 029 is yielding 59, and it should be yielding 64. No, 68. Okay, so it's quite a bit off. Let me just take an example case here, right? Let me copy you. Okay. So in this example case, we have left, down, then left, then empty string, left, down, left, and then right, up, then down, then empty string, then left, up, then right, then left, left, down, left, down, left. Okay, I mean, oh, because we can't go left, down. We could do down, left here. Yeah, okay. I'm gonna do down, left, represent that one. And then we have right, up, down, up, left, down, right, up, left, right, up, right, empty string, down, up, left, okay, down, left, right, up, empty string, down. Okay, so how many of each do I see? See 1, 2, 3, 4, 5 empty strings. So 5x that. How many lefts? Just pure left. 1, 2, 3. 3 times pure left. What about pure downs? Let's see, 1, 2, 3, 4 pure downs. Okay, and then how about pure rights? 1, 2, 3, 4. 4 pure rights. Pure ups. 1, 2. 2x pure up. And then I see what is this? Let's do right up. Right up. Okay, and then down left. And then down left, down, sorry, left down. And then left up, right up. Okay, so let's first see, does this add to what I think it adds to, right? So we have 5 plus 6 plus 8 plus 8 plus 4 plus 8 plus 8 plus 6 plus 6 plus 9. Okay, that's not good, because that's not what... that doesn't add up right at all, right? Maybe it does. Actually, maybe it does, yeah. Oh, it does. Okay, cool. Now the question is, what are we getting, right? We're not getting anything even close to that, which is awkward. Okay, wait, I do have this, right? I don't have this. I do have this. Okay. How do we go from 3 to 8, by the way? Like, how does that happen? Oh, okay, that's fine, I think. I think I get how that happens, actually. Okay. So let's actually just do a sneaky here. Do that. Yeah, so all of them should be giving the exact same result. Oh, oops, this is one layer wrong. Let's add it here. All right, so this becomes 58. Why does it become 58? Because it should become 68. Let's see how this differs from my numbers. Oh, okay, so this is already different. And then let's record the differences. So we're missing one of these, and then right up 2 is one less as well. So 1 right up, then left up 2 is fine, down 3, so 1 down as well. And then down left 2 is fine, left down 2 is fine, left 2, I see 3 less. Right is 3, I see 4 right. And then right up is 2. Yep. And then up is 2. Okay, so we're missing quite a few things actually. In fact, we're missing. What? That means we must have extras, right? Because this adds 1, this adds 4, and these each add 2. Oh no, this adds 3. Okay, never mind. That's correct, yeah. So we're missing one of a lot of things, which is not ideal. Let's see if I can back out from here why it should be. So we start with 3 blanks. So the 3 blanks map to 3 blanks. That's pretty easy. Right up should map to, we can find it, right? Where is the right up? Right up is here. So we go, this A maps to here, this A maps to here. Right up is what brings it back to the A. Okay, and then, yep. Okay, no, so this is near the end. It's almost exactly at the end, actually. It's this part. So right up should map to a down, a left up, and a right. Is that what left up maps to? So yeah, right up. Right up. Right up maps to a down, a left up, and a right. Cool. That seems right. I think probably I'm just forgetting to go back in some cases. I should also just figure out where I'm missing the extra empty, right? So the 3 empties maps to the 3 empty, that's fine. So the first one is down, left, left. Down, left, left. Down, left, left does have one. Okay, and then what is the other one? Ooh, finding the, okay, here. Oh goodness, where is that? So let's see. Why does this AA occur? Oh, because there's an AA here. Ah, okay, so that explains that one. And then there's left, left, up. Sorry, right, up. Which should also, wait, what? Yeah, okay. This is quite confusing then, no? Because this one maps to 3 of them, and then this one should map to 1, and this one should map to 1. Get default, plus val. Yeah, this is confusing to me. Let me think. Oh my goodness, why do I have that? Okay, that didn't change anything apparently. Which makes even less sense. Yeah, this makes no sense. How are there only 4 cases, right? Like, adding 3 to empty, adding 1 to empty, adding 1 to empty, and then empty is 4. That is some BS right there. That is some real BS. How is this possible? Adding 3 to empty brings it to 6. What? Huh? Oh, it shouldn't be map. It should be result everywhere. Oh my gosh. Okay. Let's bring this back to 803. Again, let's do a quick place all of these. No, it's still not right. Are we closer? Everything is 68 now. Well, that's interesting. Obviously not right. Oh, right, because I'm hard forcing this. Right, get rid of that. Well, that's a number. That is a number. No, it's too high. At least part 1 is right. The fact that it's too high is weird, though. Given it works for 1 cycle. Right, like... I guess maybe something here isn't optimal? Like, should down, left... No, down, left, left should be more optimal than left, left, down, right? I mean, I can try both. Do I even have a left, left, down case? No, never mind. I mean, wait, we can just, this should be trivial math to do, right? Like, down, left, left would be down, left, A, right, right, up, A, right? So that's what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 versus the other option is down first, down, like down, left, left versus, oh, left, down, left. No, we can't do left. We can't do left, left, down. It's not even a possible case. There's left, down, left. That's obviously worse. Like, is there a case basically that we're maybe not hitting in these, that we're hitting when we go here? I guess is the thing I'm trying to think about. Oh, wait, just to make sure I'm doing this right. What was it in the past? 1 directional that I'm using, 2 that the robots are using, 1 numeric. Right, so this is the 1 numeric, and then this is the sort of like, yeah, okay. Is this the same number? 262? I really wish Advent of Go told you what your previous wrong guesses were, but that's alright. Yeah, those sure look the same. Yeah, they are in fact the same. Okay, what we could also do though is just go to like, we know that going to 7 is possible, right? So then we can go to 18 here. Still looks the same, doesn't it? Sure does. Some of the complexities, yeah. That is strange. Very strange. I mean, so I'm doing the exact same thing I'm doing the other way, which means I don't think that's wrong. I think the issue is that I'm just wrong somewhere in here. Down being down, up. Don't see how that could be wrong. Down. Yeah, this also seems like it couldn't possibly be wrong. Left being down, left, left, and then right, right, up also seems pretty solid. Left, left, just adding a empty seems very solid. Up being left, and then right seems, yeah, pretty impossible to do better than. Down being left, down, yeah, that's strictly superior than down left, right? But we can try down left. I mean, it's so much worse, I'm sure. Yeah, 291 something. Yeah, definitely worse. Okay, so undo. And then right up versus upright. I don't think that matters. I don't even think do we even have a right up case? No. Which I think is fine. Because right up, what is right up? Right up. Yeah, I mean, could there be any differences? I mean, I think upright is better, right, actually? well, wait. So actually, let's just check. So up, right could be done with left A, left, and then either right down or down right. Let's do right down A, then up A. So that's if we did it that way. The other way is we could go down A, and then left up A, and then right A. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. The issue is like this way you have a down that's solo. This way you have down that's with another character. Like maybe that's just more efficient. I mean, we can try it, right? What is this? Up right versus right up. Upright. So upright involves going left and then right first. Left and then right. Oh, wait. Left and then right down. Yeah, sure, right down, and then up. Is that better? Wait. Well, that is better. It's a lot better. What? It's like a ridiculous amount better. No, it's still not right though. Why is it not right? Why is it so much better? That feels wrong. I guess it's not that much better. 2-1 divided by 2-6. But this means that here we should also be preferring upright. Wait, what? Did that get worse? 2-1-8, 2-1-7. Wait, how is upright here better? But then, wait, how is right? Yeah, right up here. Oh, right, because upright is literally illegal. Okay, yeah, that makes sense. But like this one is not illegal, right? Ah, that makes it better. Right, okay. I mean, kind of just throwing things at a wall at this point. Alright, yeah, I'm at the 5-minute timeout. It's fine. And I mean, numeric just generates all cases. Like it doesn't do any sort of nonsense with hard coding. Well, okay, it hard codes a couple values, but it has to hard code those. Upright. Yeah, okay. Is there anything else that could be improved? Actually, do we use what? Oh, we use right up here. Up, right. Up, right. Do we use right up anywhere else? Okay, that one's required. Here. This one should be up, right. Up, right. Up, right. Up, right. I mean, what is going on now? This is not right anymore. 72, 70, 68, 72, 66. What? That's not good. It's not good. Should have written down what the correct values are. But let's go back, I guess. Nope, you're still wrong. Change a few more. Still wrong. Oh, interesting. This has to be right up? Wait, 1, 1. 1, 1 to 0, 2. Why does that one have to be right up? Why can't this be upright? Huh? That doesn't make sense to me. Okay, now this value is just so much smaller. It's crazy how much smaller it gets. Yeah, I can't even try it. Was I even going to try the right value? I was, okay. At least there's that. I don't get why this one's not possible. Like, why can I not set this to upright? Feels like it's just better. Something is wrong here. Something is wrong. Okay, it's also past 4 a.m., so that's lovely. Yeah, I'm using longs, so I'm not worried about these numbers being too big. Oh man. Yeah, I don't get why upright doesn't work. Like why upright isn't more efficient in general. Right, because upright is a left, upright, a left followed by a down right or a right down, right down, followed by an up. Yeah. So like a down, yeah, a down could be expressed as a left down followed by an upright. I'm so confused. Like, why would this not... Well, I guess maybe a better question is, why does this matter for the other case, right? Like, in the actual, like, 2 case. Like, I mean, I should be able to come up with an example that requires a single down press, right? Let's do A963, I don't know. Actually, we don't need to just do inputs equals new string array 963. And run just you. So 62 system.println current layer up, and then down. Yep. Okay, and then becomes left AAA, right A. Okay, see a bunch of right ups. But like, couldn't those just become up left, up rights? It's basically any case where you have any case where you go from, yeah, this one doesn't make sense to me. 1 1 to 0 2. 1 1 to 0 2. Why can't you be upright? Yeah, I got nothing. I got nothing. I don't know. Okay. Ugh, this is my first day admitting defeat. Let's go see how other people on the leaderboard are doing. Okay, I'm not the only one struggling. There's a couple other people who haven't finished. Ugh. Okay. Not great, but it is what it is. Yeah, okay. I'm gonna end it here. I'm about to get 3 hours of sleep at this point. If I get it, I will post it onto GitHub and you can read the rest of the solution there. See you guys tomorrow.